Hey guys, and welcome back. My name is Miss Danielson, and today we're graphing simultaneous equations to solve them. We'll be looking at both linear and quadratic equations today, but you should definitely have a fairly good grasp of solving linear simultaneous equations algebraically, as well as graphing straight lines. If you need to brush up on these skills, I'm linking some lessons in the description box down below for you. If you're ready to start, let's get into it. Before we get started, you must know the very basics. Solving simultaneous equations means finding the values of the unknown variables that would satisfy two or more different rules or equations at the same time. So for example, here I've got one equation. X plus 3 is equal to y. And this equation has an infinite number of possible solutions. For example, if x is equal to 0, 0 plus 3 would be 3, which would mean y would have to be equal to 3. So x equals 0 and y equals 3 is one of the possible pairs of values that satisfy this rule. Another possibility is if x is equal to 2, then 2 plus 3 would be 5. Y would have to be equal to 5. That's another possible pair of solutions. Also, if x was equal to -7, -7 plus 3 would be equal to -4, in which case y would be equal to -4. So x equals -7 and y equals -4 is another pair of possible solutions. Notice that the y value always depends on what x value I substitute into this equation, so I could go on like this forever. If we want to find the values of two different variables, we need two different rules or two different equations to help solve them. So if I have another equation like 2x minus 2 is equal to y, these two different equations or rules work as two separate hints at what x and y must be. Now there's only one possible pair of x and y values that will work together in both equations at the same time. That's what simultaneously means. Both of them at the same time. You should have already learned how to solve this algebraically, but we can also solve this graphically by graphing these two equations. You should notice that these equations are both linear equations, although we like to write our linear equations in this format. Y equals mx plus c, where you should have learned that m represents the gradient, that's the steepness of the line, and c represents the y-intercept, or where the line crosses the y-axis. So let's just turn these equations around. X plus 3 equals y is the same thing as y equals x plus 3. And 2x minus 2 equals y is the same thing as y equals 2x minus 2. So now that I have them in the y equals some number of x plus some number format, I can clearly see what the y-intercept and the gradient are. For this first equation here, for example, I can clearly see that the y-intercept is positive 3. That means that my line is going to cross the y-axis at positive 3. That is 1, 2, 3 up from the origin. And I can see that the gradient is positive 1x. If there's no number in front of the x, that means there's one of them. So that means from my y-intercept at positive 3, my line will go up 1 as I run across 1. Every time I run across one square, it goes up 1. That's a steepness of 1 on a positive sloping line, which crosses the y-axis at positive 3. Let me just label that. And I always use this zigzag or lightning bolt arrow so I don't get it confused with any other lines on my graph. My second equation I can clearly see has a y-intercept of -2. That's 2 units below my point of origin. And it's got a gradient of 2. So the second line will be steeper than the first one. So if I start at my y-intercept of -2, if I take 1 unit step out to the right, I have to climb up or rise 2. 1 step out to the right, I rise up 2. Let's draw this line in there. Every 1 step I take out to the right, I rise up 2. Let's label that again with a lightning bolt arrow. And you can see that these two lines will cross at this intersecting point up here. Notice that the pair of x and y values that follow both rules simultaneously are the x and y values found at the point of intersection of the two lines, because that's the one point that follows both of the rules. So here's my solution. Now my solution isn't just a point. That point has an x and y value attached to it. So my solution is the coordinate 5, 8. That is, my x value is 5 and my y value is 8. You can always check your answers by substituting them back into the original equations. So if x is equal to 5, 1 times 5 is 5, plus the 3 makes 8. I'll substitute that into the other equation as well, just to make sure it works for both. If x is 5, 2 times 5 is 10, minus 2 is 8. So the pair of values 5 and 8 work for both of my equations. That's why that coordinate falls on both of those lines. Now that last graph gave us some exact answers. We could see exactly what the x value was and exactly what the y value was at the point of intersection. That's not always the case, however. Sometimes our graphs will cross at 2 points which are not exactly on the line. They may be some decimal value, so just before the line or just after the line or halfway between two lines, in which case you're just going to have to estimate your solution. So let's move on to some nonlinear equations. So we're going to graph curves now. You should notice that one of these equations is still a linear equation. The one in red is still a linear equation. And we can see from the format that the y-intercept is -3, so it's going to cross the y-axis down here at -3. And I can see that the gradient is +1. So every time I take one step out to the right, I go one step up. I go one more step out to the right, I go one more step up. I go one more step out to the right, I go one more step up. And it continues like that, following that pattern all the way along the line. Let's use our lightning bolt arrow to label that and move on to our next equation. You should notice that the second equation is not going to be a straight line. It's not a linear equation. It's certainly not in the form y equals mx plus c. The one thing that tells me it's definitely not a straight line is this power of 2 we have on the x. Anytime I see x squared in an equation, I think of a quadratic. And I know that when I graph quadratics, they form either a positive parabola shape or a negative parabolic shape. Now, which one is this one going to be? Is it going to be a positive parabola or is it going to be a negative parabola? You should be able to tell because there's a minus sign in front of the x squared term that this is going to be a negative parabola. So when we graph it, it's going to look like a big frown. Parabolas, or quadratic equations, aren't as easy to graph as straight lines are because they don't just have a y-intercept and a gradient. There's quite a bit more to it than that. So let's start by setting up a table of values. Often the question will tell you which values to plot your graph from. In this case, I set up my table of values to graph from -4 up to +4. So the question would probably tell you to set up the graph for where x is greater than or equal to -4, but less than or equal to 4. Note the values I've put here for x, -4 up to +4. Now it's just a matter of substituting these values into your equation. So if x is equal to -4, we'll do 7 minus, and then don't forget to use brackets around this, put brackets, and then -4, close your bracket, and then square it. -4 squared should be +16. So this ends up being 7 minus 16. Now 7 minus 16, that's -9. So I'm going to plot that point on where x is equal to -4, y is equal to -9. Next, if x is equal to -3, again using brackets, we'll substitute that into our equation. 7 minus, and then in brackets, we'll put brackets -3, close your bracket and square it. And I know that -3 squared is +9. So this ends up being 7 minus 9, which I know is going to be -2. So again, I'm going to plot that point on my graph when x is equal to -3, y is equal to -2. Our next point, where x is equal to -2. Again, using brackets to do 7 minus, and I'll put brackets, -2, close my brackets and square it, and I know that -2 squared is +4. So this will be 7 minus 4. 7 minus 4 we know is now +3. So again, I'll plot that on my graph. When x is equal to -2, y is equal to +3. Next, I'm doing x is equal to -1. So again, 7 minus brackets, -1, close your brackets and square it. I know -1 squared is 1, so 7 minus 1, that's 6. Again, plotting that, if x is -1, y is 6. Next, if x is equal to 0, well, that's pretty simple. 7 minus 0 squared is going to be 7 minus 0, which is 7. When x is equal to 1, y is equal to 7 minus 1 squared. 7 minus 1 is 6. When x is equal to 2, y is equal to 7 minus 2 squared. 2 squared is 4, so 7 minus 4 is 3. Again, when x is equal to 2, y is equal to 1, 2, 3. Plot that on the graph, and you're starting to see the symmetry of the curve. So our next point is where x is equal to 3. 7 minus 3 squared is 7 minus 9. That's going to be -2. So when x is equal to 3, y is equal to -2. Finally, when x is equal to 4, 7 minus 4 squared means 7 minus 16, which is -9. Plot that last point, and let's graph that curve. Nice smooth curve going through all of the points that we've just plotted. Let's just draw our lightning bolt arrow. Now we can look at our graph and figure out what our solutions are. And that's right, it's plural. There is more than one solution. Here's one intersecting point. That is a point that's on the curve that's also on the line. And that point is approximately -3.7 and -6.7. It's a bit past -3, closer to -4 than it is to -3. And it's a bit past -6, closer to -7 than -6. So I'm estimating -3.7 and -6.7. The other point of intersection is over here. And that's nearly at 3 along the x-axis and just a little bit down from 0 on the y-axis. That's approximately 2.7, -0.3. Again, these are estimates because I can't see the exact answer, but they give me a good idea of what the two solutions might be. Let's go on to some practice now. First, we're going to start with some linear simultaneous equations. So you're going to need to set up a set of axes, graph these straight lines, and find their points of intersection and clearly state what x and y values satisfies both sets of rules. Go ahead and hit pause and give that a go, and we'll take up the answers in a minute. Then we'll do some practice of non-linear simultaneous equations. Remember to graph in pencil and use a ruler to make this exact. I hope you had a chance to hit pause, because here come your answers. For question 1, you should notice I've got one positive sloping line. That's the y equals 2x minus 3, which is my blue line, and one negative sloping line, y equals -x plus 3. They cross exactly at the point 2, 1. So the x value is 2 and the y value is 1. For question 2, we've got two positively sloping lines this time, but one's definitely steeper. Can you see which one's steeper? The red one's definitely steeper, and that's the y equals 3x minus 7 line. Those two lines also cross at one exact point, and that's where x is equal to 5 and y is equal to 8. Question 3, again, has got one positive sloping line and one negative sloping line. Can you tell which one's which? Y equals 0.5x plus 3 is the positive sloping line, the blue one. And y equals 5 minus x is the negative sloping line, the red one. And those two cross at approximately 1.3, 1.7. Question 4, again, has two positive sloping lines, but one of them's definitely steeper. y equals 2x minus 7 is going to be steeper than y equals x. So y equals 2x minus 7 is the red one, and y equals x is the blue one. And those two lines cross at the point 7, 7. So x equals 7 and y equals 7. Let's go on to some practice of linear and nonlinear simultaneous equations now. You should be able to recognize which of these equations are linear and which of these will be parabolas. You should also notice which ones will be positive parabolas and which ones will be negative parabolas. But you'll need to set out a table of values in order to plot the points accurately and graph these parabolas as clean and smoothly as possible. So go ahead and hit pause now. Set up your axes, use a pencil, plot those points carefully, and make sure your curves are nice and smooth and they go through all of your plotted points. I hope you had a chance to hit pause, because here come the answers. For question 1, you should see that there's 2 points of intersection, so 2 sets of solution. One is where x is equal to negative 1.8 and y is equal to negative 1.8, and the other where x is equal to 2.8 and y is equal to 2.8. Question 2, we've got a negative parabola this time. Again, there's 2 points of intersection. One of them is where x is equal to negative 2.6 and y is equal to negative 3.6. And the other is where x is equal to 1.6 and y is equal to 0.6. Question 3. Again, we've got 2 sets of solutions. One where x is equal to negative 1.9 and y is equal to 7. And the other where x is equal to positive 1.9 and y is equal to 7. Question 4. Again, our 2 points of intersection. One is where x is equal to negative 0.7 and y is equal to 1.3. And the other is where x is equal to 2.7 and y is equal to 4.7. Now, in all of these cases, I've had to estimate my answers. They are not exact. How did you do with that? Hopefully your graphs are looking fairly neat and you're able to graph them accurately enough to make an estimate at your solutions. If you're having any difficulties with this or any doubts, please let me know down in the comments section. Also, let me know if you think I've made any mistakes, because that does sometimes happen. Otherwise, just keep practicing. It does take practice, so do take the time for it. Keep up the good work, and I'll see you soon.